Assalamu alaikum students. In this lesson we are going to study the basic things of electrolysis process, the electrolyte, electrodes, cations, anions and the preferential discharge of the ions. Electrolysis is a process in which electricity from a battery passes through an electrolyte, which is a liquid in solution or molten form. The plates that carry electricity into the liquid are called electrodes. Electrodes are generally made up of metals and they can be of the non-metal like graphite because it is the conductor of electricity. Graphite is a carbon. So these electrodes, they are connected to the battery and they are dipped in the liquid electrolyte and they make the connection of the battery to the electrolyte when electricity passes through the electrolyte. Electrolyte is a liquid. For example, we have solid sodium chloride, the common salt. When we dissolve it in water, then it becomes the solution of NaCl and it behaves as an electrolyte. Or when we heat up the solid sodium chloride at very high temperature, you know that at the temperature above 800 degrees Celsius, the sodium chloride melts and its ions get free and then it behaves as an electrolyte. So when the sodium chloride in the solution form or in the molten form, it behaves as an electrolyte because its ions get free and they are not held together by the electrostatic force between the opposite ions. The ionic substances are the electrolytes. Other examples of electrolytes are the acids, alkalis, or other salts, whether in the solution or in the molten form. The covalent substances are non-electrolytes because they do not contain ions. For example, the glucose C6H12O6 and the sucrose C12H22O11, these are the non-electrolytes. Whenever the electricity passes through the electrolyte splits up into ions or it decomposes into ions. The ions are of two types, the cations, which are the positive ions, and the anions, which are the negative ions. Cations are attracted towards the cathode, which is the negative terminal of the battery, and the positive ions, they are attracted towards the negative terminal of the battery, cathode. We have the list of cations, the potassium ions, K+, sodium ion, Na+, calcium ion, Ca2+, magnesium, Mg2+, zinc, Zn2+, iron 2, Fe2+, iron 3, Fe3+, lead, Pb2+, hydrogen, H+, copper 2, Cu2+, silver, Ag+, gold, Au+. So these are various cations or the positive ions. Now we have the list of anions because they are attracted towards the positive terminal of the battery called anode, and the anions are the negative ions. These are the anions: sulfate ion, SO4 2 negative, nitrate ion, NO3 negative, hydroxide ion, OH negative, chloride ion, Cl negative, bromide ion, Br negative, iodide ion, I negative. Now we discuss about the selective discharge of ions. Discharge of ions means that the charge of the ion is removed. For example, we have the cation K+, it will be moving towards cathode, the negative terminal of the battery, and it will get reduced and it will get neutral. K+, by the addition of one electron, it will get neutral, and at anode, the anions, which are the negative ion, for example, chloride ion, that will be moving towards the anode and it will get oxidized, its negative charge will get removed and it will get neutral. So oxidation takes place at anode and reduction takes place at cathode. Now we have the list of the cations and the anions according to their preferential or selective discharge. The ions, cations and the anions, the ions at the top, they are easy to get discharge, and the ions at the bottom, when we move at the bottom, it becomes difficult for the ion to get discharged. So we have this list of cations Ag plus, which is easiest to get discharge, then Cu plus, then H plus, then lead ion Pb2 plus, then iron 2 Fe2 plus, then zinc Zn2 plus, then magnesium Mg2 plus, then calcium Ca2 plus, then sodium Na plus, and then potassium K plus. So potassium is the most difficult to get discharge. Similarly, we have anions, and the anions at the top, it is easiest to get discharge, and the anion at the bottom, it is the most difficult to get discharge. So hydroxide ion is the most easy to get discharge. Then iodide ion, then bromide ion, then chloride ion, then nitrate ion, and sulfate ion at the bottom, it is the most difficult anion to get discharged. We can understand the selective discharge of the ions through the electrolysis of dilute. So here we have the example of electrolysis of dilute solution of NaCl sodium chloride to understand the selective discharge of ions. The ions present, cations are Na plus, H plus, and anions are Cl negative and OH negative. The sodium chloride splits into Na plus and Cl negative, and water also splits into H plus and OH negative. Now we have two types of cations, and we see that which cation is going to get discharged at cathode. Hydrogen ion is going to get discharged at cathode. It will get reduced. It will form the hydrogen atom, and the two hydrogen atom, they are going to make hydrogen gas at cathode. Now we see the position of the cation in the list of preferential discharge of the ions. We see the hydrogen ion is at third position, and the sodium ion is at second last position, which is most difficult to get discharged. So hydrogen ion, H plus ion, it will get discharged. Now we have anions, two types of anions, chloride ion and hydroxide ion. Now we see that which one of these anions is going to get discharged. We see the position of these anions. The OH ion is at the top. It is the most easy to get discharged, and the chloride ion at fourth position, it is difficult to get discharged. So hydroxide ion at the anode, it is going to get oxidized, and it is going to make the oxygen gas at anode in case of electrolysis of dilute solution of sodium chloride. This is the equation for the oxidation of hydroxide ion, 4OH negative. They're going to make oxygen gas molecule plus 2 water molecule plus 4 electrons are released in this process.